Okay, so welcome back. So this is in continuation of the previous video that we have on GREET model. So in this particular lecture, we will be looking at, or this particular video will be looking at a case study of the application of GREET model in different real world scenarios. Again, we would like to make it very clear that this project is not associated with the GREET model, though we are very much grateful to the Largon National Laboratory for support at points throughout the project to help us in terms of understanding the different scenarios for decarbonization of the transport sector, and also making their resources available for our use, including the material that is being covered in this particular video. So let us get started. So November 7, like the GREET, there was this is a GREET training workshop was done where they, this is their website, which we talked about in the previous video as well. So GREET Excel version is completely transparent with there are multiple modules is there, energy, fuel, product module is there. GREET 1 is the fuel cycle and 2 is the material cycle. And then they also have this different modeling technique in terms of stochastic modeling or CCLUB modeling, or where they kind of try to look at, as you can see over here, energy, fuel, products, stochastic modeling part, the land use changes, vehicles, material. So it's completely all the data and everything is available. So in terms of application of this, for example, in India, we can take that GREET model and try to use the data which is India specific data, especially when we are talking about vehicles, material, land use changes and all that, and adopt that particular GREET Excel version to the Indian conditions. So the GREET framework, the GREET 1, as we mentioned earlier, it's a fuel cycle. So it includes entire supply chain of energy production, well to pump, pump to wheels and well to wheels. And then it interacts with GREET 2. So GREET 1 model, as you can see, fuel cycles, well to pump, and then your pump to wheels are there. Then wheel 2 is your GREET, that is GREET 2 series, where you are making the your vehicle, and then recycle. The GREET 2 model is the vehicle cycling model. So GREET 1 and GREET 2, they get fed, they interact with each other, and then they also complement each other there too. So it's an LCA, it's a Microsoft Excel based LCA tool. There are 59 tabs in GREET 1, so you can download and also kind of look at that. And then there are 51 tabs in terms of the different energy sources and fuel production. Then you have all these different your material uses, and all those things are being captured over there. So major components, if you can look at, there are petroleum, energy fuels, there are intermediate products, there are applications, and also supporting information. So applications where you are looking at different mode of transport, intermediate products, your chemical, catalysis, enzymes, agricultural inputs, then energy, different types of energy there, and then what are the emission factor, fuel specs, time series values, those things kind of get into there. So each tabs, if you go into each tab, they include detailed modeling parameters enabling comprehensive LCA. So you can look at each of this tab and you get the detailed modeling parameters. Then in terms of methodology, say if you look at the well to pump, so fuel pathways, you start from energy sources like coal, natural gas, oil, renewables or whatever, and then you are it goes into your exploration and recovery, crude from the crude oil, the transportation of crude, petroleum refining, fuel transport, fuel combustion. So that becomes your well to wheels. So from oil well to the wheel of the transport vehicle, and then we have the emissions coming out from there. Let's get the pointer. So we have the emissions coming out from there. So in terms of say if you look at similarly, if you look at an example of like a biofuel, fuel pathways of biofuel. So you have the farming, and then from farming the carbon, so you have the CO2 via photosynthesis being captured, then you put some energy, you are getting some fertilizers. So you have this energy and fertilizers, your NTO coming out, nitrogen oxide getting released, carbon in soybean, now that oil gets extracted. See, then part of the extraction process, again some emissions, you get this soya meal. Again, in every step you are putting energy and chemicals, then carbon in soya meals and CO2 emissions. You could get all these naphtha, diesel fuel, fuel gas, and the carbon which kind of goes in after hydroprocessing, you got those products, then your carbon in jet fuel being used, and then CO2 again emissions. So carbon cycle via photosynthesis provided key CO2 benefits with biofuel pathway, because that CO2 again getting captured back into. So, that is called like a biogenic CO2 that we talked about. So, GREET 1 example fuel production pathway, here you have the crude recovery, you are putting energy, material, you have upstream emissions, then you are producing crude, refining processes, again energy, material, there will be upstream emissions with that. After refining you have gasoline, diesel, fuel, so co-product handling. So, here you have combustion emissions coming out in every combustions, emissions, non-combustion emissions, those things are there. So, in terms of co-product handling, what we have to kind of think about, see any process you do, you have the feedstock, you have energy, you have material, the process, and then you have this main product, you have co-product 1 and co-product 2. Now, how you allocate this co-product 1 and co-product 2? So, that is your allocation factor. So, main product and co-product carry energy and emission burden and can be allocated based on their relative ratios in the total product state. Allocation can be done based on mass, energy or market value. So, you can either do it to mass base. So, if you got say if you got main product out of 100 kg, you got main product as 60, 20, 20. So, that is your mass allocation, or energy potential from each one of them, or how much they will cost, what is the market value. So, either way of that you can do the allocation there. So, co-product handling in terms of main product carries the burden of all process energy emissions and all life cycle energy and emissions of the displaced products are credited to the main product. So, whatever the displaced product you get, say you are making a certain co-product you are trying to produce, which will be used which will displace certain other material, and then there is a carbon benefit because of that, and that gets credited to the main product. So, you have the feeds, again same thing, main product, co-product, then you have a counterpart, and you look at all these emissions coming out because of this substitution of the product, and then that benefit gets transferred to that. So, transportation process, all different transportation process, we look at the different parameters in terms of domestic like a transport and all, energy consumptions, distance, modes here and all that. Similar to earlier, it is energy use, criteria pollutants, greenhouse gases, water consumptions, all these things are captured. So, that was for the GREET like in terms of from the well to pumps, and then from pump to wheel, like the vehicle operation side, you have to think about the vehicle being operated on road, air, rail or marine. So, you have this fuel cycle where the oil is there from well, and then it is to pump, and then pump to wheels. It is going to be used in different applications. So, there are different types of conventional spark engine, different types of vehicles like light duty vehicles, includes key vehicle technologies, and then types of fuels that is used for key vehicle technologies. For all those different types of vehicles, as well as for the fuels, we do have kind of it does get covered as part of that, as part of the GREET. So, we look at the fuel economy as well as the emission factor based on Argonne's AutoNIME, which is detailed vehicle simulation model. So, they have a vehicle simulation model. So, based on that we get fuel economy values. Emission factors based on the EPA's MOVES model, which is now MOVES 3. And light duty vehicle include 3 types: passenger cars, sports utility vehicles or pickup trucks. So, we used of those the different types of trucks out there. So, heavy duty vehicles, we also there is a fuel economy and emission factors, again combination of long haul trucks, short haul truck, heavy duty vocational vehicles, pickup trucks, refuse trucks, school buses, transit buses, intercity buses, and then all those vehicles, all those different types of energy which gets used for that. So, here also and then we rail, marine, aviation module is there, which for different functional unit they generate the results, different emissions factor which is required. For rail, we got it from per ton miles or per passenger miles. For marine, again per million ton kilometer or per defined trips. Aviation, per passenger kilometer. So, all those based on that we get the emissions factor. So, and then time series is also done in those because there is a technological advancement over time. So, we to take care of the simulating the temporal effects. So, many major parameters have time series values. So, depending on the selected simulation year, GREET reads the parameter in that particular table for the relevant parameter of the simulation year. So, you can simulate, like you can different time period, as you can see on this table. So, you can have the different time period and look at what are the different energy sources and what would be the associated emission factor. So, with this, all these information or all these tools which is available, what you and I can do with the GREET. So, you can create different scenarios, you can simulate various fuel production pathways. So, in your country, in your region and all that, you can also take this model and you can create the scenarios, you can change the value, the users can change the values wherever the yellow highlighted is there, and also can select an option, the different options are also provided. And then we can work with the GREET team to even help develop like a country specific, as you saw in Canada and in China and other places they have already done. So, that can also be generated and can be adapted. So, it does help. So, of course, see, this is developed in US. So, there will be many factors and many information, so many data which is for US specific, but we can always say, as long as we do not have the, say, India, if I am coming from India and I do not have the India specific values, we can always it's kind of start our exercise with the US specific numbers, and then based on we can always change those values, and we can look at how it could be kind of incorporated. So, in terms of one of the, as mentioned earlier as well, GREET generates substantial reliable data sets for all the energy and transport technologies, and good thing about that, it has a transparency. You can understand all the information has been made available on the website. So, feedstock specification, fuel, major parameters of various material, vehicle fuel economy. So, all parameters, conditions and assumptions are clearly documented in the form of technical reports, memos and journal articles. So, and that helps in terms of adapting this to other countries. So, it also identifies hotspots and opportunities for technology improvement. Results can be presented at the process level, showing the contribution of major parameters, can help reduce environmental impact through multiple options. So, you are looking at say in terms of soybean, canola and Canada, we can in terms of the GHG emissions, and in terms of whether it is from farming, whether it is from NTO due to fertilizers, NTO from nitrogen fixation, fertilizer production, NTO from biomass or transportation. So, we can compare like where the hotspot is and where the opportunities are in terms of reducing the carbon footprint. So, as you can see on the right hand side as well, here you are looking at GHG emissions of jet gram of CO2 per unit of energy there. So, for the different petroleum, corn, gasification, fuel switch, renewable energy. So, you can look at the different in terms of how much greenhouse gas emissions are coming out. So, and that helps us to make decision in terms of what kind of energy we should go for. So, it is a stochastic simulation features are incorporated in GREET as well. It assigns probability distribution function. It specifies the number of samples required and sampling technique, forecast variables. So, you can propagate the uncertainty, you can statistically analyze and come up with the different scenarios. So, sensitivity analysis is also incorporated, which helps reveal the impact of each parameter as you measure. As we know, the sensitivity analysis helps us in terms of when you keep all other parameters the same and just change one parameter, how the data will vary. So, then in terms of GREET 2, we have the vehicle and material analysis. So, you look at the vehicle cycle, includes the entire supply chain, well to GREET 2, well to wheels, wheel cycle, the cradle to, and that becomes your cradle to gate. So, in terms of the GREET model, so here in the GREET 2, we are looking at the vehicle manufacturing all the way to the vehicle disposal. So, vehicle cycles from material recovery to vehicle disposal. So, raw material recovery, material processing, vehicle component, vehicle assembly, then finally vehicle disposal. So, it's 60 plus material are included in GREET 2, ferrous metal, non-ferrous, plastics, vehicle fuels, several important lightweighting material is also included. Major expansion in battery materials, electric vehicles, we talked about that as well, free propulsion technology, we talked about that in the previous slide. We looked at this like you can use both fuel production as well as the vehicle manufacturing cycle, you can combine them together and get the entire picture from GREET 1 and GREET 2. So, in terms of the vehicle cycle, again general structure, you start for different energy sources, different materials, you get the vehicle, and then how to basics, how to, for an example. So, you have the different inputs coming in. So, your flubber production process, your production, the flubber ore is there, and then you are getting flubber out, and you are putting all these input energy materials and water. Then you have all the emissions and NOx, SOx, carbon dioxide and etc. Going out. So, in terms of this flubber over here, you need into the input, you need flubber ore mining as well, which is again emissions there for that, which to get the flubber ore. Then in terms of flubber production, then you have some co-products. So, you get vibranium and then you also get certain other co-products. So, that can be looked into there too. So, in terms of everything can be captured, gradually built into your model. Similarly, for a steel production, so model is step by step from ore mining to part product, because many of those parts are steel. So, steel production, so what kind of iron ore mining and coal is needed. So, sintering, pelletizing, then cooking, blast furnace, basic oxygen furnace. So, steel production, steel parts for production. So, you can be like a BOF steel or EAF steel, all those things can be is being included, and then finally you get the steel auto parts. So, again same thing which we talked earlier, you can take all this energy, air emissions, greenhouse gas and water pollution. So, we can also look at the treatment of recycled material, like how to recycle method, like primary material burden, then also secondary material, like where you are looking at the secondary material content. So, you can calculate what is the because of the secondary material use, how much is the improvement in terms of the carbon footprint. So, end of life recycling method is also incorporated. So, it does take into account the materials and material processing create supply chain. So, every vehicle is a collection of components which are collection of different materials, and they come from the different sources. So, supply chain impact of material life cycle. So, battery component in terms of, and then electric vehicle has been modeled as well in the new electric vehicle production use, and EOL is there. So, approach to develop a materials inventory, bill of material. So, so similar exercise, which is again all these exercises are available on the GREET model. So, if we have to adapt it for the say to the Indian industry, so we have to look at all these different information which has to be collected from the Indian industry and need to be built in. So, that was actually one of the component of our project of this particular funded project through which we could produce this so like a small module on LCA and related to infrastructure and decarbonization of the urban infrastructure. So, in Indian context, one of the major challenges we faced is getting the data. Even some companies which are out there, the data sharing part, it's always there is still a lot of hesitation. So, I would request my friends in the industry that unless we need to have this kind of a trust building where we can collect this, we need to work together and then get the data from the industries, and then to use the model. We can start with the GREET model, we need to tweak it to the Indian condition, unless we sit down on the same table and make those deliberations, it will not be possible. Then all those BVV contains many critical minerals, so those are also being incorporated. Then available vehicle powertrains and classes. So, they have tried to bring whatever is the latest technologies from after the GREET is a work in progress every time, like they keep on improving their model, and then it is there, and it can be again it's a good tool which could be again can be taken up and Indianized for the Indian conditions and being used as well. So, it's again some of the data from autonomized detailed vehicle simulation models which they use, vehicle component, size through iterative process, vehicle specification output is there, some example is this. So, what can we do with the GREET? Again evaluate vehicle cycle greenhouse gas emissions, how will it transition to alternative powertrain impact. Current technology shows greater GHG impact from alternative. GREET provides a breakdown of impact by vehicle system. Battery size clearly impact. So, we can look at the current technology, future technologies, how this impact will change. So, it will help us a lot in making a more informed decision making, policy making. So, coupling with detailed well to wheel analysis with vehicle cycle can provide us with the C2G impact. So, total seat impact can be incorporated. So, current technology and the future technology, all those could be there. Cradle to grave is small scale SUV GHG emission. What is the current picture? So, as you can see, all those different emissions coming out, current technology. Now, you look at the future technology in terms of the base fuel. So, most of the base fuel technology, the greenhouse gas emissions, GHG emissions gram per CO2 equivalent per mile is on the lower side. So, what component of those future emission associated with vehicle cycle? So, that we see at the bottom, production burden, and then the bottom line you see that per production burden, and finally, how can we decarbonize through different energy pathways. So once we know all that, so how can we go that red bar, have to move this red bar towards the bottom as much as possible. So how we can do that. So those things can be done as well. So again, we'd like to acknowledge the great research effort at Argonne National Laboratory. They really helped us with providing us all this information, and also had during the course of the project, we had a few interactions with them, and we do have a plan to work together on this sector even after this, when the project gets over. So thank you very much, and I hope this the different short-term course that we have on LCA with focus on decarbonization of urban infrastructure, urban transport infrastructure, is useful to you. And any questions or anything, you can always get in touch with me, with us. So these were the contributors on the GREET 2022 contributors, and we are in touch with Michael Wang on a regular basis, where we do interact. So thank you. Any questions or anything, you can always get in touch with us. You can find this is our email address, and phone numbers are right there. You can always we are always available for any help. So thank you, and we'll look forward to seeing you in the next video.